Right now, Planet 9 is still warping the outer solar system, and Caltech has no way to stop it. Their own math predicted it. Their own telescopes have searched for it. And it is still out there, bending the paths of worlds we can actually see, completely invisible, completely unstoppable. But here's what nobody is telling you: they're starting to think it isn't a planet at all. Beyond Neptune, where sunlight is so faint it barely qualifies as a glow, there is a region of space that doesn't behave the way it should. The Kuiper Belt, a vast ring of frozen debris left over from the birth of our solar system, should be spread out evenly, randomly scattered in every direction. That's what every simulation of solar system formation predicts. That's what the physics demands, but it isn't. 6 of the most distant objects ever detected out there, objects orbiting so far from the sun that a single trip around takes 10,000 years, are all tilted the same way, all clustered in the same narrow band of sky, all pointing like compass needles toward something massive lurking in the dark. Caltech astronomers Mike Brown and Konstantin Batygin ran the numbers in 2016. The odds of this being random? 1 in 15,000. Something is out there. And here's where it stops being a math puzzle and starts being something stranger. Whatever is causing this gravitational clustering has to be enormous. The models say it's roughly 10 times the mass of Earth. An ice giant, a frozen world larger than Neptune, drifting in a slow, elliptical orbit so far out that at its farthest point, it swings 150 billion miles from the Sun. 150 billion miles. For context, Earth is 93 million miles from the Sun. This object's maximum distance is more than 1,500 times that, and yet it is absolutely controlling the behavior of everything around it. The gravitational grip of something this size, this far out, shouldn't reach back far enough to influence the orbits we're actually measuring. But it does. Every new object they discover in the outer belt aligns with the prediction. Every single one. Here's the problem: they should have found it by now. Since 2016, the world's most powerful ground-based telescopes have swept every region of sky where Planet 9 should appear. The Subaru telescope in Hawaii, the Dark Energy Survey, multiple coordinated search campaigns totaling thousands of observation hours. Nothing. It doesn't show up in infrared. It doesn't show up in visible light. It doesn't emit enough heat to ping our best sensors. Brown and Batygin keep refining the search corridor, keep narrowing the window, and it keeps not being there. But that's not even the part that worries them. In 2019, a team at Harvard floated an idea quietly, almost carefully, like they weren't sure they wanted to say it out loud. What if Planet 9 isn't a planet? What if it's a primordial black hole not formed from a dying star, but one born in the first seconds after the Big Bang, before any stars existed at all? Harvard physicists Jacob Scholz and James Unwin published the calculation. A primordial black hole with 5 to 10 Earth masses would be roughly the size of a bowling ball, an object you could hold in your hands. It would be completely invisible. It would emit almost no detectable radiation under normal observation. It would not reflect sunlight. It would not appear in any telescope scan looking for a planet-sized object, because it isn't one. But here's the strange part: it shouldn't be possible at all. Primordial black holes of this mass range are theorized to exist, but we have never confirmed a single one. Not one. The entire concept sits on the outer edge of accepted physics, in the territory where the math technically works but observation has never caught up. And yet it explains everything the orbital data is telling us, better than a planet does. There is something out there with the gravitational signature of a world, the thermal signature of nothing, and the physical size of a piece of sports equipment. Think about what that means. If it's a planet, we've somehow missed a world 10 times larger than Earth hiding in our own solar system for the entire history of human astronomy. Every civilization that ever looked up. Every astronomer from Galileo forward. Every space telescope we've ever launched, all of it, and we missed our own neighbor. If it's a primordial black hole, it rewrites particle physics. It confirms a class of object that theory predicts but science has never directly detected. It means the dark matter debate just got significantly more complicated. And it means there may be others, scattered through the galaxy, invisible, drifting silently through other star systems, some of them moving through regions we assumed were empty. Either answer breaks something we thought we understood, and Caltech's search is still running, right now, tonight. So here's the question nobody wants to answer directly. If it is a primordial black hole, small, invisible, locked in a long, slow orbit around our sun, how many more are there? And have any of them already passed through parts of the solar system we actually care about? Drop your answer below.